Much for giving me this opportunity to speak with you. Can you hear me? That's better, I guess. What I'm going to talk about is slightly different. I'm going to talk about how do you derive the value out of data and thereby use this value to derive the knowledge-intensive technologies in the knowledge-intensive economy. Data scientists across the world are using data and machines to behave like humans. They create products, they create functions drawn from insights and inferences. They're actually changing the way the organizations and citizens learn. However, we practice data sciences or data analytics. We draw insights. We extract learning. We try to find arbitrage opportunities, statistical arbitrage or information arbitrage. We formalize them. We apply them to solve the puzzles. And then that's why we experiment. We use the case studies and develop analytic frameworks. And these frameworks are based on two fundamental principles, and only two fundamental principles. First is that all decisions are multidimensional based on multidimensional information. And when I say multidimensional, it's never a one single data set or one or two single data sets. You use multidimensional data or multidimensional information, or what we call the high dimensional information. The second principle is that there are many small decisions which are taken to or lead on to a big decision. Like, for example, if the Federal Reserve changes the interest rate or a company launches a new brand, there would be many small decisions are taken to a big decision. And therefore, that every small decision, there would be a small multidimensional decisions that lead on to a big decision. Now, if you go back to the history, there used to be a time when the numbers served the data. And then early rendition of, say, data sciences and analytics can be seen in Jaipur, Jantar Mantar in Jaipur, India, where astronomical instruments were used in order to predict, say, eclipse or the star locations, and so on and so forth. And then Chris Menard's early depiction of data visualization when he projected the fate of the Napoleon army when he was going for Napoleon's army when they attacked Moscow. But then came the first industrial age, and then we learned how to centralize everything. We centralized workplace. We centralized education by forming schools and the colleges. We centralized healthcare by introducing hospitals. We centralized energy. And then we built then lots of networks like transportation network, the infrastructure network, the waste network, or the water network, and so on and so forth. And then we codified some of these networks, such as traffic signals. We used symbols, and then we learned how to use the symbols. We also used codified delivery system, much like in probably some of you may know in Mumbai, there's a Dabbawala concept where the residences, the lunch boxes are pretty much codified and then delivered to the workplaces. And the error rate in that is like 1 out of 6 million. which is better than Six Sigma. And during the pace, the engineering capabilities have evolved. And if you look at the first railroad when it was authorized, and then it took almost, the first engineering institution came in 1891. After almost 40 years, the first railroad was built. So therefore, you have to ask this question: that who were these people who were designing this railroad tracks or railroad or the rail engines and so on and so forth. And then until 1932, the engineering has become an academic curriculum. It was first Dr. Patrick Blackett, who introduced the concept of operational research, and then Anthony Beer used the operational research in the business, and that's how the whole use of statistics or machine learning came into being, into analyzing the business value. Now, if you look at the STEM and the number of disciplines as of today, there are as many as 89 engineering disciplines. Physics, looking at the nuclear physics or the nanophysics or quantum physics and so on and so forth, there are as many as 78. There are 75 biology disciplines, and mathematics would be 119, and then chemistry 49. Now, we also, during the process, we centralized data through data warehouses. And then we invited data scientists or big data analytics to come in and dig and try to find out some kind of philosopher's stone. And now, increasingly, we see also, I heard, some kind of creating data lake. I just wonder whether if we are trying to figure it out as some kind of insights from a swamp. But as we move on, we are moving towards the second machine age, and where we are seeing the computation is much more distributed. The workplaces are more cellular. We are looking at the education, it's becoming more cellular. Transportation, we see increasingly more bikes on the streets than the cars in many parts of the world. The infrastructure networks, such as the water network or the waste management network, looks like nowadays the internet. And we are also seeing that the cellular customers, and one customer is being dealt one at a time. The social computing is here, local and mobile computing is here, and we're also seeing the machine-to-machine where the data is generated. Now, as we see more and more data coming in, social, mobile, local, machine-to-machine, we are looking at more and more multidimensional data into the decision-making process, and thereby building a knowledge network. Now, if we do the knowledge network build-up, we need a cohesive work where the researchers, the business, the sciences, the standards, as well as the expertise. How do we build the capabilities across the entire ecosystem in order for us to drive the value from the data? And that's where the challenge is. And now, when we build the knowledge, and as we transfer the data and the knowledge which we derive, and there are two types of knowledge which we gather. First is the explicit knowledge, which are already codified, stored, and then which can be transferred from one to another. But there is something called tacit knowledge, which are not codified or not explicitly known. For example, then when you're dealing with a natural language process, and then when you're dealing with a natural language processor, you are using English language. Now that English language could be different in different contexts. Like English language used in the medical science would be completely different in the English language for a stand-up comedy. I mean, if you are familiar with various. Now, when you use natural language processing, you have to understand the context, and then how do you capture that context in real machine language. However, there is a gap in the industry, and here is the thing which I truly believe. And there is something called data collection exercise, which is where you all the cloud and gather the data from the various applications, and then you do the data computation, where you put all the machine learning, the models, all the statistical methods, and so on and so forth. And then the data comprehension, where you draw the insights, inferences, and then build on the strategy. The real oil, if the expression goes, the data is the new oil, the real oil is in the insights and the comprehension, and not in the collection or the computation. But the business problem that you are trying to solve, and then the insights and inferences which you would like to draw, will determine what kind of computation which you would like to do, and thereby what kind of data which you would like to collect, not the other way around. Now, I was recently in a session where I was sitting there, and somebody told me that, don't worry about this data collection part and the data computation part. That can go into India and China, and we can focus on data comprehension part, which is the business insights, in Singapore. And I found that, you are already distancing yourself from the data. And more you're distancing from the data, and more you are allowing other people to screen the data and filter the data, more you will be away from the power the data brings and what it would be available to them. So therefore, the idea is to bring the whole collection, the computation, as well as the comprehension together here in Singapore. Now, we are also looking at some of these, what we call the self-organized initiatives, and then self-organized learning. Here is a thing which has happened in Drachten, Holland, where there are no traffic signals. It's a self-organized traffic system, and they're experimenting it, whether people will self-regulatory scenario. Now, we have seen the self-organized trading in the high-frequency trading market, where the machine automatically executes certain orders. And then we are also finding there are coins, or the new type of currencies are coming into the marketplace, which are not determined by the Federal Reserve or the central banks, but it has been defined by the self-organized value. So we finally found the philosopher's stone, which is essentially the technology, the economic value, and then cognitive design. When I say that cognitive design, the way you present the information makes a profound impact on the value, on the behavior of the people. Now, as we know that as we go into the growing disruption, and as we go into the more and more data, and they become more and more relevant for the decision-making process, those data will be less and less monetizing prospects. But we are also seeing that the many small networks are coming in. It's not just one social network or one transportation network, but there are many small networks which are emerging, and where the people or machine maintain relationships with other people who are similar to each other, or what we call the homophils in English. And as we try to understand these relationships using the machine learning technique or the deep learning technique, we try to determine the relationship between the photographs and then audio, the video, and so on and so forth. And then we try to draw inferences. We get a better picture. And as we go into deeper into it, we find the relationship much like brain of the human being, which is far more denser. And if we go into the brain of the human being, the way the brain processes the information and derives the conceptual reasoning, and then therefore the decision-making process, it becomes a very, very interesting process. And the brain of the human being, or there is a scalability issue. The brain of a mouse could be like 200,000 times smaller than the brain of, say, an elephant. But yet, elephant blood system or the brain system is far more efficient than the brain of a mouse. And it is a theory which is called the allometric scaling, or wrench and roll. And then based on that, the same can be applied is the way we analyze the data, the way we do the computation, and then way we handle the big data. The data is also transforming the production system in the economy, and the data is becoming the part of the economic value. And therefore, there is a choice coming in. Earlier, it used to be the choice between the labor-intensive technology versus capital-intensive technology. Now we have a choice between the labor-intensive technology versus capital-intensive technology versus knowledge-intensive technology. And there has to be a trade-off between the three, and then one would be dominating the other. And how do we make those choices will determine how do we drive the economy. Therefore, coming back to the same question, that how many disciplines we can have in the data sciences or data analytics. I mean, is that only one data science and data analytics? I think the data sciences for healthcare, health data scientist will be completely different than the machine-to-machine data scientist, or the data scientist for manufacturing or the logistics data scientist will be completely different than, say, social data scientists. And thereby we can create multiple disciplines and cater to the economy. So with that respect, how are we changing in Singapore? First, we are building products or digital products which will address the questions, the topics, and then which will try to analyze the data in terms of possible answers, evidences, and then build the confidences, and focus on inferencing rather than collection and then computation. Second, we are trying to see that the protection of the data and the protection of people in terms of protection of the data in terms of security, and then protection of people in terms of anonymity. Now, you must have heard me saying in many other forums that there's a concept of Switzerland of data. And then Switzerland does two things. One, very good way. One is that they anonymize the data, and then second, they add value to the data in order to drive business. And then third is a talent development. And we are trying to put together programs which would build more and more capabilities within the industry as well as within the government. And one of the program probably we will introduce, and we are still exploring, is how to build the center of data expertise in various organizations. And then to determine how do we impact the organization, and then what kind of academic program which would require in order to impact that. And so how do we build the internal capabilities of data and decision expertise, both within the industry as well as within the organization. We'll explore that. Anyway, so my last slide. So Herb Simon, one of the finest economists, once said that we need a high rate of rapid communication among the people who perform activities that are highly interdependent. And I see that the industry, the agencies, as well as the researchers and the whole ecosystem needs to communicate more often. And then much less frequent communication is required among those carrying the activities that are dependent. And this distinction should be clearly reflected in organization structure. The systems whose structure reflects those properties are referred to as nearly decomposable. So if we design complex systems to operate efficiently, we must incorporate near decomposability in the design. If we have that design in our data science and analytics community, then we will be able to ensure that more people are spending time with the system, create more such system that the people want to spend more time with, and as the better the system, the more time people will spend with it. Help us to build a smart nation. Thank you.